Hi everyone, in this video we're going to practice determining the asymptotes of a graph of a rational function. First of all, let me remind you that there are three types of asymptotes that a graph of a rational function might have: vertical asymptote, horizontal asymptote, and oblique or slant asymptote. And let's reverse the steps that we need to take in order to identify each type of the asymptote. Vertical asymptotes occur at values of x that make the denominator equal 0. To identify a horizontal asymptote, we need to choose the appropriate case. If the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote will be the x-axis. If degrees are the same, then horizontal asymptote will be a line defined by the equation y equals a sub n over b sub m, which represent the leading coefficients. And if the degree on the top is greater than the degree on the bottom, then the graph will not have a horizontal asymptote. And finally, the oblique or slant asymptote. It occurs if the degree of the numerator is exactly one more than the degree of the denominator. In this case, to find the equation of the asymptote, we need to divide the polynomial from the numerator by the polynomial from the denominator. And the result, we're going to obtain a linear equation that defines the oblique or slant asymptote. Let's use this to help us identify asymptotes for the next four functions. For each function, we're going to check if the corresponding graph has a vertical, horizontal, or oblique asymptote. Okay, let's start. So to identify vertical asymptote, we have to check what values of x make the denominator equal 0. For that, we take the denominator, set it equal to 0, and solve the resulting equation. In this case, it's x equals 3 over 2. And that will be the equation of the vertical asymptote. It's a vertical line that crosses the x-axis at 3 over 2. Same as 1.5. To identify horizontal asymptote, we have to compare the degree of the polynomial in the numerator with the degree of the polynomial in the denominator. In this case, the degrees are 4 and 1, which means that the degree on the top is greater than the degree on the bottom. And that's the case when the graph doesn't have any horizontal asymptotes. This comparison also helps us see that the graph will not have an oblique asymptote. For that, the degree in the numerator should be exactly 1 more than the degree of the denominator, and that's not the case here. Let's try our next example. To identify vertical asymptotes, we have to look at the denominator and see what values of x make it 0. And as I look at x squared plus 1, I realize that nothing will make this expression equal 0. X squared is always positive, and then plus 1 make this expression greater than or equal to 1. So that's how I know that this graph will not have any vertical asymptotes. Now, if you want to show this algebraically, you can still set the denominator equals 0 and solve the resulting equation. But what happens is that solutions to that equation are non-real numbers, plus or minus I. That's the imaginary number. And we don't use non-real numbers for graphing purposes. So this confirms that the graph of this rational function is not going to have any vertical asymptotes. Next, let's talk about a horizontal asymptote. For that, we have to compare the degrees of polynomials, and we can see that they are the same. And this means that the graph of this function will have a horizontal asymptote. Let's determine its equation. It's obtained by taking the leading coefficient of the numerator, it's 4, and placing it over the leading coefficient of the denominator, which is 1. Well, it's x squared, but the coefficient is 1. 4 over 1 equals 4. That means that the equation of the horizontal asymptote is y equals 4. In other words, it's the horizontal line that crosses the y-axis at 4. And finally, the oblique asymptote. We check back the degrees of the polynomials, remind ourselves that they're the same, which means that there will not be an oblique asymptote for the graph of this function. The degree on the top is not 1 more than degree on the bottom. Let's look at 2 more examples. To identify vertical asymptotes for the graph of the function k of x, we take the denominator of this function, set it equals 0, and solve the resulting equation. I'm going to use the quadratic formula. I found that this equation has 2 real solutions, 1/3 and -3. That means that the graph of the given rational function will have 2 vertical asymptotes at x equals 1 over 3 and x equals -3. These are the equations of the vertical asymptotes. To identify a horizontal asymptote, we need to compare degrees of the polynomials. The degree of the numerator is 1, and the degree of the denominator is 2. And since 1 is less than 2, or degree of the numerator is less than degree of the denominator, the graph of the given rational function will have a horizontal asymptote, and it's going to be the x-axis, which is the same as the line that has equation y equals 0. And finally, the oblique, or slant, asymptote. For that, we check if the degree of the numerator is exactly 1 more than the degree of the denominator. Well, and obviously this is not the case. So the graph of this rational function will not have an oblique asymptote. And finally, our last example. To identify vertical asymptotes, we check what values of x make the denominator equal 0. And we can see that here it's going to be -3. To find this algebraically, I solve the equation x plus 3 equals 0. Next, to identify horizontal asymptote, we're going to check the degrees of the numerator and the denominator. It's 2 and 1. So the degree on the top is greater than the degree on the bottom. And that's the case when the graph doesn't have a horizontal asymptote. And finally, the oblique asymptote. We just said that the degree of the numerator is greater than the degree of the denominator. And that's exactly 1 more. That's when the graph of a rational function has an oblique asymptote. Now we need to find the equation of the oblique asymptote. For that, we're going to divide the numerator by the denominator. This qualifies for synthetic division, so that's what I'll use. Here are the coefficients of the first polynomial. And in the box, I place the number that's opposite to the one that I have here in the second polynomial. I start by bringing -2 down, then it's -3 times -2, which is 6. I place it here. -3 plus 6 is +3. And I repeat the cycle. -3 times 3 is -9. I place it here and add -2. The last digit at the bottom is always the remainder. We don't really need it here. But the other two numbers are the constants in a linear expression, or I should say linear equation, that defines the oblique asymptote. So this is our answer. And now, after we practiced identifying asymptotes of a rational function, we're ready to graph. You'll see that in the next video.